Assalamualaikum and hi, we are from Group 1 and for the Student-Centered Learning, which is SCL for MTS 3101 Calculus 1, our group have decided to solve the problem of task 1. Before that, I will going to introduce our group members. This project has been a collaborative effort with each member of the group. The first of our member group is Aida Christina Alia binti Suhaimi 228316, and then Nur Aina Christina binti Azrin 230181, Sharmin Najwa binti Abdul Rahman 230801, Nurul Khadijah Azwa binti Ariadi 230232, and Nur Husna Aina binti Abdul Hamid 228385. For the question of task 1, our primary objective is to find the demand function by assuming that it is a linear. And then, how should the ticket price be set to maximize revenue? By leveraging theoretical knowledge and practical tools, we aim to demonstrate how optimization techniques can be applied to real-world scenarios. This project explores the domain of optimization problems, which we are focusing on maximizing revenue. Optimization problems are critical in various fields, which we are aiming to find the best possible solution under given constraints. With each member of the group bringing their expertise to different aspects of the problem, we utilize some methods to analyze and solve the problem effectively, which by using the demand function to express revenue as a function of ticket price and maximizing the revenue function by finding the ticket that yields the highest revenue.
I will explain how to solve the problem regarding the demand function and ticket pricing to maximize revenue for a stadium. So, let's start with question 1A. We are given two data points. When the ticket price is RM30, the attendance is 13,000. And when the ticket price is RM20, the attendance is 23,000. From the data given, we can simplify it as when x1 equal to 30, y1 equal to 13,000, and when x2 equal to 20, y2 equal to 23,000. Since the demand function is in linear, we can write it as y equal to mx plus c. Where m is the slope of the line, we calculate as m equal to delta y over delta x. So we can substitute m equal to y2 minus y1 over x2 minus x1. And then we get m equal to negative 1000. Now substitute this value of m into the equation and we get y equal to negative 1000x plus c. To find c, we use one of the points, either x1 and y1 or x2 and y2. So in this case, we choose x1 and y1. And then we substitute it and we get c equal to 43,000. Therefore, the demand function is y equal to negative 1000x plus 43,000. Next, let's move to question 1b. First, let's recall that revenue denoted as capital M is the product of ticket price and attendance. So we write it as M equal to X multiplied with Y. From question 1a, we know that demand function is Y equal to negative 1000X plus 43,000. And then we substitute this into the revenue formula. We get M equal to negative 1000x squared plus 43,000x. And then step 2, to maximize revenue, we need to find the critical point by differentiating M with respect to X, which is dm over dx equal to negative 2000x plus 43,000. Next, we set dm over dx equal to 0 to find the value of x. And then we solve it and we get x equal to 21.5. So the ticket price that maximized revenue is Rm21 ringgit and 50 cent. Finally, let's calculate the maximum revenue by substitute x equal to 21.5 into the revenue equation. After substitute, we finally get m equal to 462,250. Therefore, the maximum revenue is Rm 462,250 ringgit.
So hi, I'm Shamina Javed Rahman with method number 230806. Represent to you the method we use for solving these questions. For the first question, we use a simple linear regression equation methods, or we call it a least square regression methods. So for this question, we use a formula of y equal to mx plus c, where the y representing the number of the spectators, meanwhile x represents the price of the tickets. So the goal of this method is actually to find the best fitting line that minimizes the sum of the squared difference between the observed value of y and also x. So for the next question, the method used is actually maximizing revenue. It is one of the applied optimization problem that commonly used for business of all sizes, and it is used to find the optimal combination of pricing and also sales volume to generate the highest possible revenue. So in this question, we use m equal to xy, where m represents revenue, x represents the price of the ticket, and lastly, y represents the number of the spectators. And then to determine the ticket price that will generate the maximum value, we relate the demand function we get from the previous question in this formula.
So for the result and implication, the optimal ticket price that we got from the calculation is 21 ringgit and 50 cents. At this price, the attendance will be 21,500 spectators out of 45,000 spectators in the stadium. So the maximum revenue will be 462,250 based on the 21,500 spectators.
Lowering the ticket price from 30 ringgit to 21 ringgit and 50 cents significantly increases overall revenue, clearly demonstrating the trade-off that exists between ticket pricing and attendance levels, as a lower price attracts more spectators. The analysis also reveals that the stadium full capacity is not being utilized even at the optimal price point, which suggests a potential adjustment could be made to address demand and maximize attendance. This comprehensive analysis ultimately assesses the football team in striking a balance between ticket affordability for fans and sustainable revenue generation, ensuring sound financial decision making for long-term success.
With all the details explanation from our members, we conclude that through these assignments, we not only aim to solve the given optimization problem, but also gain deeper insights into the challenges and strategies involved in optimization, which contributing to our understanding of its importance and application. That's all from us. Thank you for watching.